We're going to go ahead and do our first example in our notes. You should have already reviewed the video of the properties of real numbers here, adding and subtracting fractions. So what you hopefully remember is that when the denominator is the same in two fractions, that means the numerators, you just combine the numerators. And I messed up when I started this video, so I'm starting over. So if we see the numerator of the first fraction is a 3, the numerator of the second fraction is an x minus 4. And the denominator, keep it factored, is x minus 4 times x plus 3. Keep it factored throughout. And then all you have to do here is you have to combine like terms. 3 plus x minus 4, that would be the like terms, would be 3 and negative 4. So 3 and negative 4 is negative 1. So you could either write it as negative 1 plus x, or you could write it as x minus 1, either one. And then again, just go ahead and keep the denominator factored, and there's no real benefit to multiplying out those factors, and that's it. I'm going to leave the even numbers for you. So let's look at number 3. Number 3, we can see here that the denominators are the same. They're not factored, but they're still the same. So we're going to go ahead and combine the numerators. 4n minus 1 plus n plus 3 all over. Now, you know, it would probably be better right now. I'm going to go ahead and just multiply that out, or leave it unfactored, I should say. And when I leave it unfactored, most likely I'll be ending up factoring it anyway. So let's go ahead and combine the like terms in the numerator. 4n plus n is 5n. Negative 1 plus 3 is positive 2. So be really careful. And then we have n squared plus 5n plus 4. So here I'm glad I didn't I'm glad I didn't factor the denominator, because what happens here is I know that 5n plus 2 cannot be a factor of this polynomial down here. And if that's the case, then there's no need for me to factor the denominator, because there's no way that I could cancel one of those factors with the factor that we see in the numerator. So we're going to go ahead and leave it alone. And okay, we can do another example. Number 5. I'm pausing here. Number 5. We can see we still have the same denominators, and so we're going to go ahead and combine the numerators. Now here's where it gets tricky. Now the reason why I'm pausing a little bit here is because that minus sign right there. The common mistake is just to write minus n plus 1, but that would be incorrect, and I'll show you why. Hopefully you'll see why. We have to subtract the entire numerator. This n plus 1 is the entire numerator, and so with a minus sign there, that's going to change things a little bit for us, and you'll see here in a second. So in the numerator, you have to actually distribute that minus sign to both of those terms in the numerator. So when you see a minus sign, you need to be on like tactical alert here. You got to be really, really careful. You get parentheses around that other numerator, and because that will change your answer to the wrong answer if you don't distribute this minus sign. Subtracting n plus 1 means distributing the minus sign to the n, minus n, and then minus 1 as well. So think of this too as like a negative 1 multiplied by what's inside. So you have to take the negative 1 and multiply it by both of those terms inside. And I just see so many mistakes made right there. And so hopefully you're not going to make that mistake. So let's take a look here and see what happens if we combine like terms. 2n minus n, that's going to give us n. And we have a minus 1. And then our denominator is 4n multiplied by the quantity 3n plus 1. And again, nothing else that we can do. We can't factor, or we can't cancel that factor of n minus 1 down here. So we leave it alone. No need, again, to multiply out all the factors in the denominator. We'll start another video for the second side.